Hi Jobbies. So in today's lesson we are going to have an introduction to trigonometry. So we're going to look at three things. We'll look at the quadrants, we'll look at degrees and radian measure, and we're going to have an introduction to special angles. So just an overview of what we're going to look at. So for the quadrants, you know them very well. We have the first quadrant, second quadrant, third, and the fourth one. Yeah, so we're going to look at these. So this will be a very short subheading. And then from the quadrants, we're going to look at the degree measure and the radian measure. Okay, and then from there, we're going to look at an introduction to special angles. So we have generally 5 special angles which we are going to look at. So we have the 90-degree angle, 60-degree angle. We also have a 0. The other 2 angles, they come from 90 and 60. So what is half of 90? It is 45. And what is half of 60? It is 30. So these are the special angles which we are going to look at. Okay, so I have a few things to discuss. So straight away, let's discuss the quadrants. So the quadrants, like I mentioned previously, we have 4 quadrants. So we have the first quadrant, second quadrant, and the fourth. And then now, we're going to use the mnemonic for the quadrants. We use them to determine the signs of ratios. So these ratios will have cos, sine, we'll have sine, and we'll also have tan. These are the angles which we have. So in the other lesson, we're going to add 3 more. So our mnemonic would be that we'll say all students. Okay, so this is students. So all students take chemistry. Yeah, so that's our mnemonic. So what does this mean? Here where we have O in the first quadrant, we say that all these ratios, they are positive. In here, cos is positive, sine is positive, and tan is positive. Here, all students, so S is for sine. So in here, only sine theta is positive, meaning that the other two which we have cos and tan, meaning that in here they are negative. Are you following? Yeah, so if you don't, at least you can be following through by writing somewhere. So in the second quadrant, only sine is positive, cos and tan, they are negative. And then moving on to the third quadrant, we have tan. T is, it's take. So T is for tan. So in here, so we have in here tan, it's the only one which is positive. So automatically, you know, if you look at this side, so in the third quadrant, tan is positive, meaning sine is negative, cos is also negative. Yeah, so this is baby stuff, but just pay attention. So if we have an angle in the third quadrant, if it is tan something, if we're going to have tan something, it will be a positive. But if we're going to have cos something, sine 20, cos, oh sorry, in here like sine 200. So as long as an angle is in here, if it is sine, it should be negative. Yeah. So and then where were we before? Okay. Yeah. So that's pretty much on in the third quadrant. Yeah. So we're just on the surface. We don't have to take a lot of time here. So in the next lesson, we'll come back to this. We'll refer to it more than in this one. So in here, all are positive. In here, only sign. And then in the last one, we have we are saying all students take chemistry. So in the last one, C is for cos. So in here, cos is the only ratio which has, so these are trigonometric ratios. So cos is the only trigonometric ratio that has a positive in the fourth quadrant. So that's the introduction to quadrants. So we can even have a look at one or two baby questions. Okay, so we have looked at these, and then now we can I want us to practice one baby question, and we proceed. Okay, so here we are already looking at the tutorial sheet. So I've been told to find the quadrant that contains the terminal side of the angle given the conditions below. So of the first question, sine theta is less than 0 and cos theta, sine theta is greater than 0 and cos theta is less than 0. So what this question is simply talking about, they are saying we find the quadrant given these conditions. So when they say greater than 0, it means it should be a positive. Okay, so because you know the number line very well. So on the number line we have a 0 point, and then going this side, these numbers are less than 0, and then going to the right, positive numbers are greater than 0. So if they are saying greater than 0, it means positive. Less than 0, it means negative. Okay, so you can proceed to answering. So I hope you drew that table, or it's already in your head. So we want to determine where can we find sine theta to be positive, greater than 0, meaning it's 1, 2, 3, yeah, positive. And at the same time, cos theta should be less than 0. Okay, so we draw our the table. So we are showing the quadrants. So where is sine positive? So we said in here all signs are positive. So all students take chemistry. So in the first quadrant, we'll say sine is positive. And then in the second quadrant, sine is also positive. So we know our answer could be here or there. And then let us also satisfy this condition. Cos theta should be less than 0. So less than 0 meaning negative. Okay, so already having a lot of work here. So cos theta is less than 0. So simply meaning that where is cos negative? So for you to know where it's negative, you first have to know where it's positive. So for cos theta, so let me take you back to where we're coming from. So here we are. we said cos theta is positive here in the fourth quadrant. So since it's positive here and here, so one thing you should know is that each of these angles, they are positive in two quadrants, the first quadrant and one of these. So cos theta is positive in the fourth and in the first. So it means that since it's positive here, it will mean that it's negative in these other sides which are remaining. Alright, so I hope none of your job is lost here. Yeah, so this is not so complicated. So let me also explain on sine so that at least you get what I'm talking about. So sine, it's positive here in the second quadrant and also in the first quadrant. So since it's positive in these two, it means it will be negative in these others, in the third quadrant and in the fourth quadrant. That's where it will be negative. Are we good? So getting back to the question, want to know where cos is negative. So since cos is positive in here and there, it means that it's negative in this quadrant and in this quadrant. Wherever it's not positive, it means it's negative. Okay, so now proceeding to our question. Here we identified where sine is positive. Sine is positive in the first and in the second. And then we also want to know where cos is negative. So cos is negative here and here. So we can check which quadrant is having two things. It's the third quadrant. So the answer for question 1A, you write nicely first quadrant. Yeah, so they rarely ask about this. Yeah, or unless later on when we look at the other trigonometric ratios. Alright, so proceeding to the other one. So I'm ending here, so you should check out the tutorial sheet. They are actually, this is ABC, there's also DEF. Yeah, so tan theta, or tan is less than 0 and cos is less than 0. How do we tackle that? So we want to identify where tan theta is negative here, less than 0 meaning negative. Okay, so I think we'll actually use the same, I don't know what to call this. If you know, you should comment some or you tell me some. So tan theta less than 0, meaning where is tan negative, and then cos theta less than 0, also where is cos negative. So for cos, by now we're getting familiar that cos is negative here and here, because here it's positive, there it's positive. And then we can remember our mnemonic. So we said all students take chemistry. So T is for tan. So it means that this tan is positive in the third quadrant. So tan is positive in the third quadrant and in the first quadrant. So wherever there is no plus, it means that's where tan is negative. So meaning that tan is negative here and there. So where we have two signs, that's where our answer should be. So even this is in the first. Okay, so later on you should be able to deal with this. So that is for the next lesson. So I've talked about sine, cos and tan. So later on we'll have to talk about cot, sec and cosec. So you can look it up in the lecture slides, but that will be the focus of the other lesson. So we're done with the first objective of this lesson. So we are done with the quadrants. And then now coming to degrees and radians. So these degrees and radians, they are what? They are basically, so they are simply a measure. So like if we have a circle here, the complete rotation of a circle is 360 degrees. So now if this 360 degrees it's turned into radians, it's actually 2 pi. 2 pi is equal to 360. Yeah. So next time you want to write 360, you can write 2 pi. And then what is half of 360? It's 180. And what is half of 2? It's 1. We're not going to show the 1. So this is the expression we're going to use to convert between degrees and radians. You should always remember that pi is equal to 180 degrees. So pi is equal to 180 degrees. So we don't have to suffer a lot. Straight away we go to an example. So we'll start with a baby example. If we're told to convert 260 degrees to radians, what do you do? So you are going to remember that pi is equal to 180 degrees. Okay, and I was forgetting to mention it nicely. So this is 360 degrees. So 360 degrees is equal to 2 pi rad 2 pi. So this is in radians now, where pi is involved. So we have to remember this. Pi is equal to 180. So if we have 260, what is going to be pi? We don't know. We can put x. So from there, what's remaining is finding the value of x. When you cross multiply, you get 180x. So we have 180x is equal to 260 times pi. It's 260 pi. And then to remain with x alone, we can divide by 180. So you divide by 180. Even there, you divide by 180. From there, what do you get? Continuing, we're going to have x is equal to, so 0 and 0 can cancel. We'll remain with 26 over 18 pi. Yeah, and then you can simplify further where you say divide throughout by 2. We're going to have 13 over 9 pi. Oh, yeah, so pi rad for radians. Yeah, so this is how you go about it. Are we confused? I hope not. So from here we can also we can be given something in radians here, and then want to convert it to degrees. So let's go back to the tutorial sheet. We answer something on this. Okay, so there is our tutorial sheet. So we did something on question 1, and then coming to question 2, it's where they are like, without using a calculator, convert the following angles to degrees. So whereby I've been given radians. So if I have radians, how do we convert to degrees? Yeah, so we're going to do this, and you saw something on converting from degrees to radians. So I'm going to do 2 examples, 2 questions here and 2 questions there. The other ones, they'll be for you. So let's share already. So for me, because I'm the bigger one here, I'll get this one. So this is your exercise 420, and then I'll also do this one for a negative, and then you do that, and then here I'll do this, you guys will do, oh, I'll do this and that. Yeah, I've shared. You see, I'm a very caring person. I've been sharing questions. I do these two, you guys will do this, do this, do that. Yeah, so now let's proceed to answering. Okay, so here are our questions. I want to answer question 2 and 3 of the tutorial sheet. So without using a calculator, change the following angles to radian measure. Okay, so this is our question. So I've even forgotten what we agreed on. Also, I said I'll do this one. So want to convert to radian measure. So we basically use the same principle, where we say pi is equal to 180. So pi is equal to 180. So what if we have under the degrees here, what if we have 570? What would be the angle in radian? In radians. So we cross multiply. We say 180 times x. It is, we'll say 180x is equal to 570. 570 pi. To remain with x alone, we divide by 180, and there also we divide by 180, and then we'll have x is equal to, the zeros can cancel, so it will remain with 57 over 18 pi. So the pi can be written alone here, or you will write it as a numerator, 57 pi over 18, and then don't forget to put radians. So we're done with that baby question, and then the other one is this, you can answer. We also agreed that I'll do this one for negative 45. So we'll be able to see from here. So we're saying pi is equal to 180. So what about if we have negative 45 degrees? It's going to be what? So we say 180 times x. So here we always have 180 times x. If you like stress in your brain, you can also say 2 pi is equal to 3 skis, and then you start converting, you arrive at the same. So here we're going to have negative 45 pi. Same thing, we divide by 180, divide by 180. From here we can, what's remaining is just to simplify. So we'll say x is equal to, we can divide by 5, so negative 5 into 45, it's 9, over 5 into 18, it's 3, remainder 3, and then so it's 36, and we have a pi. So 9 can go into 36 as well, so we can simplify further. So we're going to say x is equal to negative 1 over 4. So I've converted, so negative 45 degrees, it's 1 over 4. Yeah, so later on we're going to look at those special angles. We'll discuss them where we say, yeah, okay, so that's for later, but 45, later on, you always know that it's pi over 4. If it's 30, it's pi over 6, and all those. So we've done justice on question 2. So I believe you can do this one. And then here I even feel so lazy. And this one is even more interesting. So I said I'll do this, and which one? I think this. Okay, so as long as I've solved, you can do it better. So pi over 4 pi over 3. So let's convert. Always remember pi is equal to 180. So this time around, they are giving us a certain measurement in radians. We have 4 pi over 3. So this will be equal to x. So as usual, we cross multiply. So what is 180 times 4 pi over 3? Yeah, so I'll teach you like babies. I'll even show you how to multiply. So this is 180 times 4 pi 4 pi over 3. So here simply you say 180 times 4 and then you divide by 3. Or alternatively, we can divide here. So we say 3 into 3, it's 1, and then 3 into 18, that's 6. So I have 60 times 4. So what is 60 times 4? It's 240. And then we have a pi. So I've shown you how to multiply 180 by this. So 180 by 4 pi over 3, you know very well, it's 240 pi. So this would be equal to, there I will say x. X pi. You can also write a pi. Okay, so our aim is to, what's our aim here? Our aim is to find the measurement in degrees. So meaning to remain, we have to remain with x alone. Yeah, so how do we remain with x alone? We divide both sides by pi. Divide by pi, divide by pi. So this and this will cancel. Remain with x is equal to, even this and that will cancel. So x will be 240 degrees. Okay, so we have done it. I think I won't do the other one for you. Yeah, it's just that students have phobia. If you see something which was never answered in class, you get to panic. No, we have a negative. No, I don't know if I'll manage. Yeah, so you follow the same. You say You say here you have negative, or you start with pi is equal to 180. Pi is equal to 180. And then you say here under pi, we now have negative 11 pi over 4 is equal to x. So the job is just to multiply 180 by this. So you simply divide 4 into that and then you multiply. And then you divide by pi. Have answered this. So you can answer this one without much difficulty, and you can try this as well. Yeah, so don't be so lazy. If you won't be sure anywhere, you can let me know on WhatsApp. 6600 class this 49. The tutor is too tired to continue writing his phone number. Okay, so we go to the last item of the day. We have done degrees and radians. So now I want to do now an introduction to special angles. These guys. So these are the backbone of trigonometry, and later on we'll use the knowledge here under complex numbers. So follow me closely, and where you are not clear, why should you be afraid to ask? So the special angles. So the special angles, like I introduced to you, we have 5, we have 6, we have 90, 60, 0, and then the other 2, it's half of 90, which is 45, and half of 60, it's half of 60, it's 30. Okay, so I'm giving you this exercise. Now this exercise is very important. For the other ones, I know you've understood, and I don't want to see your answers unless you have questions. So now the exercise I'm giving you is convert 90 degrees to radians. Convert, please. Pi is equal to 180. So what about 90 degrees? It will be what? So I want you to convert all of these and show me your answers. Yeah. The values you get, they'll be very, very useful for what's ahead. So now, under special angles, when you convert that, actually that's what you get. So under special angles, we need to know how to interpret them very well. Okay, so you refer to your lecture slides where you find to Mafani triangles. They give you, this side is root blah blah blah, root 3. Okay, so you go through, but we shouldn't stress a lot when learning. Yeah, so we're going to use what is called the hand rule. So in science, we get to use the hand a lot. Even when you, in the last part of semester 2 physics, you are going to do electric field, where you use the hand, where we say the direction of current, and then we have these fingers. Okay, so you are going to do this. What does it mean where the thumb is pointing? The fingers are pointing this side. What does this mean? The palm is pointing this side. It's pointing the screen. What does it mean? Yeah, so that's for physics. Let us save that for later. So we have the hand rule in physics. Yeah, for those who are taking, yeah, you learn it with Mr. Mubita. Alright, so here now, in trigonometry, the hand which we're going to use, it looks like this. So we have this hand. 1, 2, 3, 4, 5. Okay, and I haven't drawn it nicely. I think I'm just so bad at drawing. Okay, so however, as long as we have 4 fingers, then it's not bad. 5 fingers rather, sorry. So the idea which you just have to know here is like remember we have how many special angles? We have 5. We have 50, we have 60, we have 0, and then half of 90 is 45, and half of 60 is 30. So now how to interpret this? So in your lecture slide you find the triangle. Now that one, it's tiresome. We have to draw different triangles, but with one hand we can make it easier. So the thing here is we need to know what cos 90 is. Like simply, how do we evaluate cos 90, sin 90? So under this one, we use the mnemonic, which is when you sin, you go down to hell. And this is very true. When you sin, you go down. So what this means is that when we have something like, let's start with sin 60. So if we want to evaluate sin 60, what we do, we'll simply say sin 60 is equal to square root of, when you sin you go down, so how many numbers are below 60? So we have 1, 2, 3. So we're going to say square root of 3 over 2. So over 2 is, it's just general. So square root of something over 2. So from now on, you should always know that sin 60 is square root of 3 over 2. Okay, let's do another one. So we can go to sin 90. Okay, we're not doing sin 90. That would be your work again. So what if we want to do sin 45? So sin 45. So as long as there's sin, just know that we're going to count the numbers which are below 45. So it says square root of how many numbers are below 45? We have 1, 2. So it means square root of 2 over 2. The denominator is always 2. Yeah, the denominator is always 2. You should know this. So sin 45 is square root of 2 over 2. Right. And then what is sin 30? Sin 30 is square root of how many numbers are below 30? On the hand, we have 1. We just have this over 2. And here the square root of 1, we know it's just 1. So sin 30 is simply 1 over 2. And then sin 0 is 0. Yeah, you have gotten it very well. Sin 90 you can manage as well. Oh, and this one is special, so let me do it with you. So sin 90, we say square root of how many numbers are below 9? We have 1, 2, 3, 4. So sin 90 is square root of 4 over 2. And the square root of 4, we know it. Square root of 4, it's 2. So 2 over 2, and 2 over 2, it's 1. So from now on, always know that sin 90 is equal to 1. Alright, we have exhausted this. From here we can go to cos. So obviously cos will be the opposite. We count the numbers which are above a certain special angle. Yeah. So always remember the hand. So this time I'm not going to draw the hand, but you know how the numbers are following each other. We have 90, 60, 45, 30, and the number of people have a crush on some. Yeah, others, did you know that the number of people crush on you are this? I don't get offended. 0 is also a number. Okay, so we continue. If we have cos 30, let's start with cos 0. If we have cos 0, we're going to say it will be square root of how many numbers are above 0. So cos it's going up, sine going down. So above 0 we have 1, 2, 3, 4. So square root of 4 over 2. And the square root of 4 we know it's the square root of 4 we know it's 2. So we can simplify further where we say 2 over 2, because here we have a 2, and this will just be a 1. So cos 0 is 1. And then what is cos 30? Cos 30 is square root of how many numbers are above 30? We have 1, 2, 3. So I have square root of 3 over 2. That is cos 30. And then what is cos 45? So cos 45, how many numbers are above 45? We have 1, 2. I'm talking about 45 and I'm writing 60. So cos 45, how many numbers are above 45? We have 1, 2. So it means square root of 2 over 2. This is cos 45. And then cos 60, you can manage, it's 1 over 2. And then cos 90, it's 0, because there's no number above 0. So we'll say square root of 0 over 2. So cos 90 always know it's 0, but sin 90 is 1. Sin 90, what is sin 90? Yeah, sin 90 is 1. So this is the introduction to special angles. Yeah, so I hope you got to learn 1 or 2 things. So from the tutorial sheet, if you look at question 3, we're going to answer it in the next lesson. So we're dealing with angles equal to 90 or less. Now what if we have cos 120? How do we find it using a calculator? That will be the focus for the next lesson. So for today we'll end just here. I hope you found this video very helpful. So let's continue with the second lesson. We'll start from here where I've ended. We now go on to, wait. So we had an intro to special angles. So later on, we're now going to look at, from these special angles, we're now going to look at more angles. From there, we do identities and we cruise just like that. So for now, bye-bye. Oh, and one more thing for those who are lazy, who are not writing, you can actually let me know if you want this. So if you want this as a PDF, what we did. Okay, So this was our little lesson for today. You can go and rest and keep on studying.